Thanks, Claudia, and thanks everyone for sticking around to the after lunch session. It's always the tough one. So with sustainable water management, why is it important to us here on the Sunshine Coast? So what are our drivers and what are our options? So back in October, and it may have changed since then, Council projected that there'd be in the vicinity of an extra 167,000 people on the Sunshine Coast in 20 years. So with extra population, you've got, of course, increased demand on water supplies. And the other thing that we've got is uncertainty from climate about what our rainwater sources are. So if we're taking a sustainability perspective and we're thinking about what can we use locally to reduce the footprint of our water sustainability and our integrated water management plans, what sources of water are available to us locally? Okay, now each of these sources have got different levels of reliability and different energy costs associated with them. So rainfall is probably the most unreliable, and it's the one that we rely on at the most. So we're really hoping it's going to land in the reservoirs where we've put them, but often a lot of it runs down the street. Wastewater, super reliable in an urban environment, and the more people you've got, the more water source you've got. So that's an option. And our location, we're right on the coast, so accessing seawater, if we wanted to put a desalination plant on the coast, is another option for us. But wastewater recycling and purification and desalination are quite energy intensive. So I'm going to talk to you about stormwater harvesting today. And when I say stormwater, what I'm talking about is that rainfall that actually hits the ground, not the rainfall that we're capturing in rainwater tanks. Stormwater is harvested and reused quite extensively across the globe. Australia does more of it than several other countries. Currently, most of our applications for that are non-potable applications. So things like irrigation and industrial use, toilet flushing, laundry uses through some third pipe systems. And we have one town, Orange, in New South Wales, that supplements their drinking water supply. Supplementation of drinking water reservoirs with stormwater occurs in two countries. So Singapore, who've been doing it since 1986 as a part of their 3-tap system, where they use rainwater captured in reservoirs, stormwater, so 2/3 of Singapore is stormwater catchment for drinking water supply, and wastewater recycling. In Orange, they first started investigating it after the Millennium Drought. So around about 2008 was when they started researching it due to water security problems. So it was quickly escalated in their integrated water management plan. They started off with Blackman Swamp Creek because they didn't have time to implement new infrastructure. So they started harvesting stormwater out of Blackman Swamp Creek and putting it into a retention dam for 90 days, and then they would put it into Suma Park Dam, which is their main drinking water reservoir. They then were developing a new estate at Ploughman's Creek. So Ploughman's Creek, they were able to start from the ground up, similar to the idea that's being investigated at Aura, and build the infrastructure from the beginning that would allow them to harvest stormwater. Some of it is reused in a third pipe system, so in that in the toilet flushing and in the laundry, and the other is directed directly to that same retention dam as the Blackman Swamp Creek plan, where it sits there for 90 days and then goes into their main drinking water reservoir. So having a think about the potential benefits that stormwater harvesting has for the Sunshine Coast, whether we use it in potable applications or whether we use it non-potable, it has the ability to reduce the demand that we have on our potable drinking water supplies, because we don't need to use drinking water quality water to irrigate parks or to wash streets or for industrial processes. The other thing that it can do is if we take out part of that stormwater runoff, not all of it, but if we take out part of it, then we can reduce the volume of water that's going into Pumicestone Passage, and we can also reduce the range of pollutants. So you have to think, well, what do we know about stormwater quality? Well, prior to 2000, we didn't really know much at all because most research into stormwater had investigated the impact on ecosystems. So we weren't looking at it from a human health perspective. So there was a national study done by the CRC for water sensitive cities that ran for 3 years, and we looked at raw stormwater. So stormwater that hadn't mixed with other water supplies. We looked at 10 catchments across Australia, land uses ranging from residential, commercial and industrial. And what we found that stormwater was really, really variable, not just across the different states, the different land uses and the different climate zones, but also across samples collected at the same site, so different events that were occurring at the same sites. We found both through our microbial testing that pathogen presence was highly variable, and when we looked at that pathogen data in relation to our chemistry data, we were seeing that it looked like that was going to be associated with sewage ingress, so broken down sewer infrastructure where sewage, or cross connections where sewage might be leaking into the stormwater. We found that pharmaceuticals and personal care products were generally either not detected or, with the exception of caffeine, detected at levels that were well below the drinking water guidelines, the Augmentation for Drinking Water guidelines, and that caffeine discussion is for another day. So we did find that some heavy metals were at the guideline level for drinking water. Also, there was some of the things that are present in petroleum-based products and products associated with combustion and things like that. The PAHs and the benzopyrenes were at guideline levels or just a little bit above, but a lot of the nasties like the herbicides, the endocrine disrupting chemicals, and the polychlorinated biphenyls were actually either not detected or well below a guideline level. So it was looking pretty promising. The other thing that we looked at was they did in vitro bioassays, and we compared, so from a toxicity perspective, what's the quality of unmixed or raw stormwater compared to something like raw sewage or wastewater that had been through a wastewater treatment plant, or of surface water or of drinking water. And what we were able to establish was that toxicity was similar to what was coming out of our wastewater treatment plants, okay? So the effluent that was already going into some natural creeks and streams. An important caveat to remember about this was, although we tried to choose really, really diverse catchments, all of our catchments had been sewered in 30 to 90 years. So some of our catchments have been sewered in the 1990s, and some of them have been sewered in the early 1900s. So that's important for thinking about how does infrastructure and drainage infrastructure change in catchments now. So the idea to investigate stormwater harvesting as a potential option for Aura was put forward. So Aura had a lot of really good things going for it. There was a drinking water reservoir right across the road, so you wouldn't require a lot of piping infrastructure to get water from one spot to the other. It was a greenfield development, so there wasn't those barriers to other stormwater harvesting schemes of having to retrofit infrastructure that occurred in existing cities and communities. And also, it uses welded sewage pipes. So this is really quite new drainage technology for sewage. And what it means is you're not having that butting together of the concrete pipes that's really prone to leakages. So there's the potential that this water might be cleaner than the water that we looked at in the previous study. So a working group was put together to investigate this. Like all good working groups, we came up with a plan, and we're just working our way through that now. The first stage was to sample some stormwater in a representative catchment. So when this was first being investigated, Aura was really early in the stage. Okay, so we wanted a catchment that had similar climate, topography, land use, and similar welded sewering. So we went right next door, actually to Bells Reach, not Bella Vista, but you'll forgive me the typo. We looked at 8 rainfall events, and what we found was that the untreated runoff, so this raw stormwater, was actually clearer than what we were seeing predominantly in that previous study. So that was really promising. We didn't detect any of the reference pathogens that the stormwater harvesting guidelines for water recycling require, which is Cryptosporidium, Campylobacter, and Giardia. None of those were found in any of our events, so that was promising as well. And our chemical findings were similar to what the CRC study had found. The next step was to start planning, so how do we look at what sort of treatment technologies we could use using these water-sensitive urban design features to treat some of the water before it got to the New Urmatic Dam. So there's a bit of desktop modelling, and then as Mike was talking about the other day, the importance of getting all the stakeholders in the room. So then getting expert knowledge from a whole range of different disciplines and local knowledge to then inform that. So the next step, what we know so far, I guess we're up to the next stage of investigation. What we know so far is that stormwater harvesting is a viable option for increasing water security on the Sunshine Coast. There aren't any technical reasons for why stormwater harvesting can't be used, and potential health risks that may occur can be managed through water-sensitive urban design treatment trains like the curbside bioretention systems, constructed lakes and bioretention ponds. And then after the water would be put into Uwamatic Dam, it would go through all the same normal treatment processes that it would get before becoming drinking water. The next stage of investigation is catchment-specific water quality data. So, yeah, that's where to from there. I think I've gone a bit quick, so either you missed all of it or I left out a slide, but someone will ask me a question.
Okay, so there are a couple of questions, and looks like we have time maybe for both. Pumps would be required for stormwater recovery. Who pays for pumping and replacement? Is it really sustainable?
Luckily, that's not a question for me, but that's one of the things that that's being investigated in the feasibility. And it's about how these systems are designed as well with the natural flow of the land. So trying to reduce the need for pumping where possible is what's being investigated by all the engineers in Stockland.
And we have a very topical question. Will it be necessary to test and treat for COVID-19 in stormwater reuse projects?
Wow, where's my crystal ball that I didn't have last February? Okay, at the moment, I don't think there's enough understanding of how COVID-19 is shed to fully answer that question. So at the moment, we know it's being shed in wastewaters. One of the benefits of this system is that it is the welded sewer pipe, so that's good. But I think that there needs to be more understanding about how COVID is shed by the human body, COVID-19, before we can start answering questions about exposure scenario. At the moment, there's still a lot of uncertainty about how it's spread between people.
Okay, thank you. Okay, there was another question. Why so much caffeine?
Have I got time for the caffeine question? Okay, we don't know. That's the answer about the caffeine. We don't know. Curiously, we thought, okay, some of our sampling sites were in inner city residentials. So you're thinking like St Kilda and Melbourne and places like that. So it's highly likely that someone might pour a can of Coke or a coffee down the stormwater drain. That's feasible, but also in our chemical testing, we did come up with things like some aspirin. So I can never get it right. There's a acyl sulfame. I think I've pronounced it correctly. It's a real trigger for me. That was turning up as well. So that and some of, there's an active ingredient in some of the antidepressants as well. The one in Prozac was turning up in really small numbers as well. So what that is doing is tying for us that suggestion that in the catchments that we looked at in that study, sewage ingress is possibly happening. There's a little bit of debate going on about could caffeine be an indicator for sewage ingress in future studies, and that's a wide open debate. So I don't study in that area, so I'm not sure about where that's going yet.
Thank you.
But please don't pour your coffee and your Coca-Cola down the stormwater drain.